What's up, friends? Welcome back. This is the Changelog. We feature the hackers, the leaders, and the innovators behind Semver. We're joined by Predrag, Gruevski, and Krycho, two Semver nerds. That's what Jared called them, and they didn't get upset. On today's show, we explore the challenges and the advantages of semantic versioning, aka Semver. We highlight the need for improved tooling around Semver, where semantic versioning really shines and where it's needed, how types can influence Semver, alternative approaches, and whether or not there's a better way, and why it's not as simple as just opting out. If you're a Semver nerd like Predrag and Chris, well, this show's for you. A massive thank you to our friends and our partners at Fly.io. That is the home of Changelog.com. With Fly, you can launch your app near your users. It's good to be near your users, and they'll help you do it with no ops. Learn more at Fly.io. All right, let's Semver. What's up, friends? I'm here with a good friend of mine, Firas Abukadije. Firas is the founder and CEO of Socket. Socket helps to protect some of the best engineering teams out there with their developer-first security platform. They protect your code from both vulnerable and malicious dependencies. So we've known each other for a while now, Firas. Well, let's imagine somehow I've landed myself at Vercel. And because I'm a big fan of you, I understand what Socket is, but I don't know how to explain it to anybody else there. I've brought you into a meeting. We're considering Socket because we want to secure our dependencies. We want to ship faster. We want everything that you promise from Socket. How do you explain Socket to my team at Vercel?
Yeah, Socket is a developer-first security platform that stops vulnerable and malicious open source dependencies from infiltrating your most critical apps. So we do that by focusing on real threats and keeping out all the types of risks that are out there in open source dependencies. Everything from malicious dependencies, typo squat attacks, backdoors, risky dependencies with hidden behavior. There's all kinds of risks out there, a lot of reasons why a dependency might be bad news. And Socket can help you as a developer just keep all that out of your app and keep things nice and clean and pristine amongst your dependencies.
I saw recently Dracula. I'm a fan of Dracula. I don't know about you, but I love that theme. Big fan of Xenorocha. And I saw there was like a misspelling there. And so because Dracula is installed on VS Code in lots of different places, I saw there was a typo squat sitting there that had different intentions than obviously Dracula did. Is that an example of what you mean?
Absolutely, yeah. Dracula, that's a perfect example. It's super common these days to see that type of an attack where you see a common dependency that you have an attacker just pretending to be that dependency, typoing the name of it by one letter and then trying to get unsuspecting developers to install it. Unfortunately, we're seeing more and more of these types of attacks in the community, and they're taking advantage of the trust in open source. As developers, we need to be more aware of the dependencies we're using and make sure that we're not pulling in anything that could risk the data of our users or cause, a big breach at our companies. And so part of that is obviously being more careful and asking questions and looking more carefully at the dependencies we use. But also part of that is tooling. It's really a hard problem to solve just on your own as a single developer. And so bringing in a tool like Socket can really help automate a lot of that work for you. It just sort of sits there in the background. It's really, really quiet. It doesn't create a lot of noise. But if you were to pull in something that was backdoored or compromised in some way, we would jump into action right in the PR or right in your editor, or even as early as you browse the web. We have a web extension that can actually give you information if you're looking at a package that's dangerous, or if you're browsing Stack Overflow and you see somebody saying, hey, just install this dependency to solve your problems. A lot of times even that can be a way to get the attacker's code onto your machine. So Socket jumps in at all those different places and can tell you if something is dangerous and stop you from owning yourself.
Yes, don't get yourself owned. Use Socket. Check them out. Socket.dev. Big fan of you, Firas. Big fan of what you're doing with Socket. Proactive versus reactive, to me, is the ultimate shift left for developers. It is totally developer first. Check it out. Socket.dev. Install the GitHub app, too easy, or book a demo. Once again, Socket.dev. That's SOCKET.dev. We're here with two awesome people that reached out via Twitter to talk about something that goes back to our roots, Jared. The very first episode of this podcast was Semvered, technically, right? Remember that?
Was it 0.0.1? Yes.
And then we got crap because 0.0.2 was not Semver, but we did it anyways. So we're here with Predrag, Gruevski, and Krycho. Welcome to the Changelog.
Thank you.
What do you think about the fact that we Semvered or tried to our podcast episode numbers?
Pretty sweet, right?
We tried for like 30-ish episodes, I want to say. Like around 30 or 40, we decided, nah, it's not going to work anymore.
But when were the breaking changes?
That's the problem, is it just wasn't as semantic as intended.
Every time you change formats, it's a breaking change, right?
If we apply Rust rules, then 0.0.x, every release is a breaking change, right? Everyone is major. So that sounds good to me.
There you go.
Technically, before 1.0, you can do whatever you want, and the versions are allowed to do whatever they say, per the Semver spec. So,
except in Rust.
Yes. And NPM, actually. They both have opinions. Hey, we just walked right into what we're here to talk about.
That's right. So we are here, if you haven't read the title, which I'm sure will have Semver in there somewhere, we are here to talk about semantic versioning with two Semver nerds. I'll just call you all that. You can take offense if you want. Not meant to be offended. Who have thought deeply on this topic. Adam and I, of course, have thought shallowly, I would say. No offense,
Very
Adam.
shallow, yeah.
Yeah, shallowly on the topic. We know it. We've lived with it. We've seen its failures and its successes. But let's get to know you by way of Semver. So, Predrag, you have been working with Semver in the Rust community. Is that right?
Yes. So I'm the author of a tool called Cargo Semver Checks, which is a linter for semantic versioning. So when you're about to publish a new version of your package, Cargo Semver Checks can check its API against the previous release and just make sure that everything's looking good, that you haven't made any breaking changes, or that if you have made breaking changes, the next release is major, not minor. So you're not going to break anyone in the ecosystem.
Gotcha. And Chris, your work with Semver is what?
Basically twofold. One, my biggest one was I spent a bunch of time, I worked at LinkedIn for about 5 years, and one of the things I worked on was TypeScript adoption at LinkedIn. LinkedIn is one of the few big tech companies that instead of doing a big mono repo for all of its code, does a bunch of small repos and uses Semver internally. And so as we were looking at how do you adopt something like TypeScript, we wanted a really good handle on how is that going to intersect with our front-end web development ecosystem, using Ember.js and using a bunch of repos using Semver internally and then also externally. And so I ended up writing a spec, which lives at semver-ts.org, for what does it mean to try to apply Semver to TypeScript, among other things, because TypeScript ships breaking changes in what the NPM ecosystem thinks of as minor releases, and also because the type system of TypeScript, and I'm sure we'll get into more of this as we go, but it complicates what it means to make a breaking change in really interesting ways. And that got me running down asking, what does it mean if you have things that borderline on, fancy types that only show up in Haskell or Idris otherwise, affecting how your Semver spec actually works? And then I recently gave a talk on this subject, which is how Predrag and I ended up talking with each other, in which I looked at, okay, what is everybody doing? What's the state of the art for how to handle versioning, whether you're in Ruby or Node on kind of one end of the spectrum, or whether you're in Rust or Elm, or when you're out there doing crazy things, and crazy in a very good way here, like what the Unison programming language can do. And just tried to say, here's kind of the range of options, and here's where we might be able to go in the future by pulling in new ideas in computer science research and so on. So I'm at least as much, like Predrag and I are competing for who's the nerdiest on Semver here.
Mm-hmm.
I think I've gone fairly deep. I'm mostly focused on Rust, and I also have done some prototyping on a similar Semver linter for Python. So I think I've gone deep, and Chris has gone wide.
Mm-hmm.
There you go. Well, if we were to stay shallow for another 2 or 3 minutes and got all of us on board with a foundation of what semantic versioning is for the lay folk, Chris, you want to define it for people?
Yeah. The big idea is that versioning is a tool for communicating with the consumers of your package, your app, whatever it may be. And Semver looked at this problem over a decade ago and said, there are a bunch of emergent ways that the software ecosystem has come up with to kind of describe the feel of these changes over time. It'd be great to give them names that we can all use to talk about them consistently and to give those names some semantics. And so semantic versioning, where the names are major, minor, and patch for the kind of typical number versioning scheme that, again, emerged organically over the course of decades prior to that. And so a patch version means this has a bug fix in it, and it's otherwise backwards compatible. A minor version means it might have bug fixes and it has some new feature and it's backwards compatible. And a major version means there are breaking changes in this. There might also be features, there might also be bug fixes. And then there's additional metadata you're allowed to tag on to the end, like this is a pre-release version. So 1.2.3-alpha.0 tells you it's an alpha release. And you can stick build metadata on the end or whatever else you want. But the big and important bit is that semantic notion of what major, minor, and patch mean and the shared vocabulary for talking about them.
And I think it's also important to think about what Semver means from a user's perspective, because when I maintain a tool and I have a few hundred dependencies, I don't necessarily want to look very closely at the various different version numbers and think about what they all mean. But what I do want to be able to do is, say, run cargo update inside my Rust project and know that because everyone adheres to what is a breaking change and when it gets published as major and not minor, the updates that cargo is going to make to my lock file are going to be backwards compatible. They're going to result in me still having a working building project at the end of that command. And this is not specific to Rust. I could also do the same thing for the NPM ecosystem and TypeScript. Let's say I could do the same thing for Python. At the end of the day, as a consumer of Semver, I don't care about the numbers. I don't care about the meanings. I just want to not have to sign myself up for fixing things that I did not intend to break, right? I ran a command. I wanted some new dependencies that are compatible with my build, and I want that to be the case every time.
And notionally, you want that to have the same basic meaning, even if you're jumping across ecosystems like Bundler and Composer and NPM and Cargo, and all of these can use the same basic language. And so your experience, in principle, we can talk about it in practice, but in principle should be the same, that you can give a specifier to your package manager and say, look, only give me minor bumps to this. And I'll take new features if they come in, and I'll take patch versions for sure if they come in, but don't give me any breaking changes. And NPM should be able to say that, and Bundler should be able to say that. And I, as a user, should be able to say, okay, cool, this is going to work the same basic way. Maybe I need to tweak the syntax a little or think about a couple different things, but it should translate across ecosystems more or less.
And I love the choice of words there. Should be. Ominous. I think we'll come back to that.
Yeah.
I mean, I think that's the big problem, right? Go ahead, Adam.
I was going to say, like, this might be like the biggest question I have for this whole show, and it might be just transcending all the topics, but it's like, is Semver poorly adopted generally or poorly misunderstood, which makes it hard to fully adopt without pain? Because, like, I feel like that's kind of hard. Like, I don't fully get Semver in all the ways. There's a lot of, y'all are Semver nerds, as Jared lovingly called you guys, you know? And so there's a level of, a depth level that you all understand Semver, that to me, if I eject and do my job, and then I come back in and Semver matters, I've forgotten all the things. And so I just wonder if there's like a lot of people like me, and potentially Jared, you aspire like I do with that same kind of thing, is you eject, you do your job, and you kind of come back and you're like reminding yourself exactly all the implications of Semver. So is it poorly adopted? And then generally to adopt it and to use it, it's hard because not everybody does it the same way.
I think it's a tooling problem, to be perfectly honest. If any kind of technology requires that you earn a PhD in it before you can be a proficient user, then it's not going to go very far.
Right.
And the rules of Semver in Rust, in TypeScript, in Python, they're not obvious. I mean, I've been doing this for years, and there's hardly a week that goes by that I don't learn about a new horrifying way to accidentally cause a breaking change in a Rust project, in a Python project, in a TypeScript project, right? So the fundamental problem here are that the rules are too complex. There's too many of them. It's too easy to break them without noticing. Chris and I have some fantastic examples of doing this in Rust and TypeScript, where the most innocuous seeming change ends up being breaking for some reason that no sane human would ever think of, right? So the real answer here is the tooling just needs to be good. We can't keep all of these rules in our head, and we need tools to do that for us. And so I authored one of these tools. It's not perfect yet, but it's getting better every day. And I think the name of the game is not to hold ourselves to an unreasonable standard of perfection and just minimize the number of times that a developer publishes a change and then wakes up the next morning to 100 frustrated users saying, why did you break my project, right? Because that's a regrettable change that happened, right? We want as few of those as possible, and maybe we get to 0 one day. I don't think we're there, but I think that trying to get as close as possible to 0 is a valiant effort, and I think we can make a solid dent in that.
I would say too, like in a multi-person project, though, you also have multiple people that can version or have implications into the versioning, and like who determines whether it is a bug fix or a break? You don't always know either. So you may unintentionally submit something to your repository or make a change, doing a release, or somebody does the release for you all. I mean, there's a million different ways it could happen. It seems like it's such a brittle process fraught with opportunity to fail.
I think that's right. One of the things that I dug into really deeply when I was talking about this at a conference a month and a half ago is exactly that dynamic. That what makes this difficult is those semantics all sound good, but the definition of a breaking change gets fuzzy. So there's a guy named Hiram Wright who worked, I'm not sure if he's still there, at Google, who coined a great law called Hiram's Law, and a coworker of his put it up on the internet at, I think it's hiramslaw.com. And it says in basically so many words, given a sufficient number of users of any API, all observable behaviors of the system will be depended on by somebody. And my observation is that the number of users is like a few dozen. It's not many. And that can be used as an argument to say Semver doesn't count or is not sensible, because anything you do can break somebody, and bug fixes will probably break somebody. This is actually the reason that TypeScript, the compiler, ships what I would think of as breaking changes in its minor releases, because their argument from a philosophical point of view is any change you make to a compiler breaks someone. So it's not sensible to have a discussion about what a breaking change is or isn't. Now, I don't actually agree with that, but I do think it gets at something really important, which is that ultimately we're not dealing in something that's purely a technical problem to be solved, because ultimately, again, versioning is about communication, right? It's about that conversation you're trying to have with your end user, often a conversation you're trying to keep as low bandwidth as possible, where they just see version number change. What do I need to think about it before they even go digging into your release notes, so that they can say, oh yeah, this one should be safe. Let me try it. Bump worked. Cool. Great. And I move on with my day. And so you have this tension of saying, what's a bug? If my bug fix, which is a real bug fix, breaks my entire user base, do I call it a bug fix anymore? And I think what that gets at is that you still need human judgment in there. And what you want is for the tool to catch all the cases which are knowable. So all the cases where you can say, no, for sure, this is a breaking change. You want the tool to tell you that. And then additionally, you're going to have things on top of that, which might also be breaking changes, where you're saying, okay, this thing might not be a breaking change in terms of, that ridiculous 10,000 word spec I wrote about TypeScript, or in terms of what cargo semver checks can catch today. But I'm looking at it and I'm saying, this one's going to break 96% of my users. I'm going to go ahead and call it a breaking change because I'm the human in charge of this and I care about my users, and I'm going to make that judgment call. So it's sort of a start with the things you can prove or know based on tooling. And that eliminates a massive amount of the argument or confusion in the space, because you can just trust the tool to do it. And then pull in the human judgment and say, does this bug fix feel like a breaking change? Okay, then it is. because, again, communication tool above all.
And this is interesting because I think it's sort of the opposite of many other linters, where false negatives are actually okay. Not only are they okay, they're going to happen no matter how we feel about them, right? Until we solve that pesky halting problem, right? Like, no Semver checker can catch everything. Human judgment is always going to be necessary. What we really strongly don't want is false positives, right? The tool saying, I found a breaking change, where that is not the case. So we want our tools to be extremely confident when they report something, and it's okay if they don't catch everything. And that's the approach that Cargo Semver checks takes. That's the approach that my Semver linter for Python takes. I just think that's the correct approach. And that's not always the right approach for every flavor of linter, right?
Right. Sometimes a false positive is safer. But here, I tend very strongly to agree. And a good example is like what Elm does. Elm has a very conservative and fairly minimal approach to the way it thinks about it. It basically just looks at the changes when you do something at a type level. You know, did this add a parameter to the function? Did it remove one? Did it add or remove a field on a data structure? And very simple checks like that. And that's all it does. But it does enforce that, and it's built into the package publishing flow. And I think that's great. Again, it leaves room for the human judgment, but it doesn't. It also sets a conservative baseline that's guaranteed to be accurate. It's never going to false positive you because any of those changes can be statically known. Nope, 100%. You made this change. That's gonna host somebody.
Right.
What's up, friends? I'm here in the breaks with David Shu, founder and CEO at Retool. If you didn't know, Retool is the fastest way to build internal software. So, David, we're here to talk about Retool. I love Retool, you know that. Been a fan of yours for years, but I'm on the outside, and you're clearly on the inside, right? You're on the inside, right?
I think so. Yeah, I'd say so.
Okay, cool. So, given that you're on the inside and I'm not on the inside, who is using Retool, and why are they using Retool?
Yeah. So the primary reason someone uses Retool is typically they are a backend engineer who's looking to build some sort of internal tool, and it involves the front end. And backend engineers typically don't care too much for the front end. They might not know React, Redux all that well, and they say, hey, I just want a simple button, simple form on top of my database or API. Why is it so hard? And so that's kind of the core concept behind Retool is front-end web development has gotten so difficult in the past 5, 10, 20 years. It's so complicated today. Put together a simple form with a submit button, have that submit to an API. You have to worry, for example, about, when you press the submit button, you got to bounce it, or maybe you got to disable it when it's, is fetching is true. And then when it comes back, you got to enable the button again. When there's an error, you got to display the error message. There's so much crap now with building a simple form like that. And Retool takes that all away. And so really, I think the core reason why someone would use Retool is they just don't want to build any more internal tools. I want to save some time.
Yeah, clearly the front end has gotten complex. No doubt about that. I think even front enders would agree with that sentiment. And then you have back end folks that already have access to everything, API keys, production database, servers, whatever. But then to just stand up Retool, to me, seems like the next real easy button because you can just remove the entire front end layer complexity. You're not trying to take it away. You're just trying to augment it. You're trying to give developers a given interface, that's Retool, build out your own admin, your own view to a Google Sheet or to the production database, all inside Retool. Let Retool be the front end to the already existing back end. Is that about right?
Yeah, that is exactly right. The way we think about it is we want to abstract away things that a developer should not need to focus on, such that the developer can focus on what is truly specific or unique to their business. And so the vision of what we want to build is something like an AWS, actually, where I think AWS really fundamentally transformed the infrastructure layer. Back in the day, developers used to spend all their time thinking about how do I go rack servers, how do I go manage cooling, manage power supplies, how do I upgrade my database without it going down, how do I change out the hard drive while still being online, all these problems. And they're not problems anymore because nowadays when you want to upgrade your database, just go to RDS, you press a few buttons. And so what AWS did to the infrastructure layer is what we want to do to the application layer, specifically on the front end today. And for me, that's pretty exciting because because as a developer myself, I'm not really honestly that interested, for example, in managing infrastructure in a nuts and bolts way. I would much rather be like, hey, I want an S3 bucket, boom, there's an S3 bucket. I want a database, boom, there's a database. And similarly, on the front end or in the application layer, there is so much crap people have to do today when it comes to building a simple CRUD application. It's like, you probably have to install 10, 15, maybe even 20 different libraries. You probably don't know what most of the libraries do. It's really complicated. To load a simple form, you're probably downloading almost like a megabyte or two of JavaScript. It's so much crap to build a simple form. And so that's kind of the idea behind Retool is, could it be a lot simpler? Could we just make it so much faster? Could you go from nothing to a form on top of your database or API in 2 minutes? Well, we think so.
Yeah, I think so too. So listeners, Retool is built for scale. It's built for enterprise. It's built for everyone. And Retool is built for developers. That's you. You can self-host it. You can run it in the cloud. Custom SSO, audit logs, SOC 2 Type 2, professional services. Starting with Retool is simple, fast, and of course, it's free if you want to try it right now. So go to retool.com/changelog. That's retool.com/changelog.
Let me make two somewhat contradictory statements, which I both think are valid. The first one is that I have been a user of Semver tooling for many years in roughly 3 different Semver-oriented camps: Ruby, Elixir, JavaScript, as just an application developer. And roughly speaking, and I know Semver enough to realize like major, minor patch, what should be safe, what should I check, blah, 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 blah. I've rarely been bitten by these problems as a user. Now, you guys are at the library level and you're like the tooling level. And so very generally, the system isn't terrible. Like we are talking about its downfalls and we are nitpicking, and there are many ways that it breaks. And the problem is we didn't know it broke until it's too late. In fact, we didn't think it was going to be a break. And so we communicated wrong. Like, these things are all issues and ones that we all butt up against, in some places better than others. But generally speaking, I think it's been somewhat of a win. That being said, with the tooling situation, Predrag, that you're talking about, and with our desire to constrain ourselves from miscommunicating, are we finding a local maximum, right? Are we trying to polish a turd, so to speak? Is there ever a solution to this problem? Is it worth saying, we can try to clean up the world that we're living in, or we can just invent a brand new world? Is Semver just fundamentally broken and we're not going to fix it? And we could probably just do versioning in a different way. Some people just ignore it altogether. Your thoughts?
I actually have some hard data to share on this. So about a year ago, 4 enterprising college students and I embarked on a journey to figure out how good the state of Semver compliance is in the Rust ecosystem. Now, Rust, statically compiled language, bias stored systems, you'd expect, if anyone is very hardcore about adhering to Semver properly, it should be Rust, right?
Yeah, for sure.
So what we did is we took the top 1,000 most downloaded Rust libraries, right? So these are extremely popular things like, Surdy and Tokyo and things like that, things that multi-billion-dollar companies depend on, easily. Right? And they're developed by some of the smartest, most experienced people in the ecosystem. And we scanned 14,000 of their releases total. We found that more than 1 in 6 of them has unintentionally shipped a Semver violation that we could find. And we found that more than 3% of all the releases contained at least one Semver violation that we could detect and could have prevented. 3% of every release means that on average, if I run cargo update once every 10 days, my project is broken once. Right? Like every, 10 days that I run cargo update, I've updated one dependency that will introduce a breaking change. Now, it's unclear whether I actually used the part of the API that ended up being broken by that breaking change or not, right? So I might get lucky and it might be okay. But now let's think about this on a population timescale, right? There aren't 10 people depending on these libraries, right? When these breaking changes happen, they break the entire ecosystem. And so thousands of people have to spend their time figuring out why the heck the build is red all of a sudden. And then maintainers on the other side have to, all of a sudden, in an unscheduled, highly stressful, highly charged environment, publish an emergency patch that either undoes the thing or whatever it was. Imagine if it was bundled with a security fix. Now all of a sudden the pressure is even worse, right? So as a user, when I run cargo update, I don't want to be broken. As a maintainer, when I run cargo publish, I don't want to break people. As a member of this ecosystem, I want the people that don't have a lot of time on their hands to not spend their time pointlessly fighting tooling in one way or another. I want all of the maintainers of all of the libraries that I depend on to not have to worry about were they broken or were they going to break somebody. So the thing here that we're talking about, sounds like a small effect. 3%, yeah, whatever, rounding error, maybe it's okay. But the thing is that it adds up. These little bits of friction here and there, they really add up when you consider the large population and the long time horizon of these projects and how many times, these projects get downloaded and used every week, right? So even though the individual impact on a single person's day is probably next to zero, multiply that out to the number of people that depend on that software, and all of a sudden the impact is pretty darn significant.
Okay, so you're saying it's not good enough as is, and tooling can improve. Can it get us into from 3% down to a minuscule fraction in which we can live with this? Chris, your thoughts on that?
I think the answer is yes. And one of the reasons that I'm more bullish on sticking with Semver and putting tooling around it is because I did survey the rest of the world, as it were, when it comes to versioning. And there are a lot of approaches that just say, these problems with Semver are fundamental, scrap it. One of them, solo ver, is just have one version number. It's 1, 2, 3, etc. Just go up. And that has a certain appeal to it. But the actual fundamental issue there hasn't changed. All it does is take the burden off of the maintainer of a library and put it on all of the users. It says, okay, now you're responsible anytime any one of your dependencies changes, including transitively, anywhere in your dependency tree, to go read the release notes, which tend to encode things like breaking changes in the release notes because, again, communication problem, right? We want to know what did this do? And so, also, as an aside, all of those proposals include things like, well, you can also stick like pre-release numbers on the end. And I'm like, but hold on. It seems kind of like we're backing our way back toward this whole Semver thing now, aren't we? Shouldn't your pre-release just be another number? I think there is a sense in which there is a maybe fundamental local maximum. Like maybe it's local, but the hill's so big that we're not going to find a different path. Could be wrong about that. But when I go looking around, the things that seem like they might change the calculus here don't so much eliminate the value of Semver as they do build on it. So a good example here is what the Unison programming language does. Pretty small language, but it is aimed at industry. It's not pure research. And they do something that's really wacky in the best way. You don't store your code as plain text. Instead, they take advantage of the fact that they're a pure functional programming language with really well-specified semantics. And they say, okay, we can take your code, normalize it, hash it, and store the compiled output of it with a pointer to it, which means a whole bunch of interesting things. But for the purposes of versioning means when I make a breaking change, the original version is still there because that hashed compiled version of it got committed to a database instead of to plain text. And that database version is what anybody who depends on it sees. So when I add a new parameter to my function, the consumers are still pointing to the old function, which means they can pull this update and say, okay, I can progressively switch over to the new function signature, but I can do that at will and the two can live next to each other. And because it is a pure functional programming language with no side effects that aren't managed off in the runtime, et cetera, leave all that aside. Suffice it to say, because of that choice, they can just, quote unquote, ship a breaking change without it ever breaking anyone. The reason you still want Semver here, though, is because Semver is a communication tool. And so Semver lets you say, okay, there are these new features in the library. Here's a bug fix. You're going to want this one. And even though that means you need to actually go update which compiled version of this function you're pointing to, you're getting data from that. And when you go to publish your library, you want to be able to use that information. Even knowing that it's not going to break your users in the same way, it does let you then say, oh, I didn't actually mean to make a breaking change here. I wanted this to be compatible and to just keep working forward. So things like that, I think, are pointers in the right direction. There's also a couple papers out there from folks at the Nova University of Lisbon who are asking, like, what happens if you bake versions as types into Java? Java, because it's the kind of default language to do this kind of research on. Their proposal is very interesting from a type theoretic and versioning perspective and would never get adopted in industry in a million years because it's just way too much boilerplate. But it does the same thing we're talking about. It bakes this notion of backwards compatibility in a way that I think would, if you were going to actually ship something like that in an industrial programming language, you would actually want Semver as basically how you do it. And their type system that they slap on top of Java effectively encodes Semver with keywords. It's like upgrades and replaces and things like that. So I think there's work to be done here, but I don't think it's going to be in the near term, for one. So we're going to need the tooling. And even if and when we see something like that type system on top of Java or what Unison is doing becoming more widespread, I think those kinds of things lower the risks in really interesting and important ways, but they would still really benefit from the kinds of tooling that we're talking about. They also, though, highlight, I think, one of the things that's easy to miss in these kinds of discussions, which is a lot of times people like me, who are type theory nerds, etc., like to go looking for that kind of a solution to a problem. It has two limitations. One is that's never going to work for Ruby. I say never, but like you could imagine a world in which type adoption for Ruby is at 100%, but that world seems very unlikely to me. Not least because a lot of people who love Ruby love it because it's dynamically typed. And second, doing all of those things purely at that, like, let's bake it into the type system level, has costs, because it turns out that that itself then becomes a thing that you need to think about in terms of the versioning of your language. Because one of the things that shows up is that the more foundational whatever your tool is, like if you're an app and you just have consumers, it's not that big of a deal. Your versioning is basically purely marketing. If you're a library, you have a bunch of apps that use you and maybe some other libraries. If you're a framework that everybody else builds on, how well you do this now affects everybody else in the entire ecosystem. If you're a programming language, you're kind of doing it at the maximum level, and you still have to communicate those versioning constraints to other people. And the more complicated your type system is, the harder it is to actually understand what the implications are for versioning. So the tendency that people like me have to say, bake it into the types, then it'll be rigorous and checked forever, can actually undermine your net goals here, because now you've made it harder to think about this fundamental communication problem.
And this is an area where Chris and I had an interesting discussion that made us feel like this would be a good podcast topic. I agree with him that building versioning into the type system of a language like Ruby or Python is not the way to go here. But that doesn't mean that we can't build Semver tooling for dynamic languages. And in fact, I've built a Python semantic versioning linter that's in closed beta with a few friends right now, but if someone listening to this wants access, find me on social media, and I'm very happy to send it your way. The core idea is that when we as programmers look at a piece of code and a change to that code, we have a set of rules and heuristics that we run in our minds to determine if something is breaking, right? A public function got deleted. A function signature changed. Now it takes a different number of arguments. A default went away from somewhere. There's nothing stopping us from encoding those rules in a machine checkable way and just have the computer go through that checklist and make sure that we didn't mess anything up, right? Now, this tool isn't doing anything differently to what we were doing. And if it finds nothing and we find nothing, then great. Just ship it as a minor and everything's fine. But on the off chance that we haven't had our caffeine that day, or we're just tired, or, we have something else going on in our mind, and we miss one of those things, and the tool catches it, that's just pure win, right? So it's those cases that I'm very interested in catching with tools. It's fine. They're never going to be perfect. I'm not perfect either. I'm just very interested in finding the spaces where my imperfections and the tool's imperfections happen to not overlap, so that at least one of us catches it.
Mm-hmm. I mean, I like that because it's pragmatic and because it seems achievable. I mean, it's just work. It's probably hard work, and I'm glad you put some of that work in. But it's really like taking that 3%, which is probably a high water mark considering it's the Rust ecosystem.
Yeah.
It's probably a much higher percent in other places.
It's actually much higher in Rust as well, because those are just the issues that we found by running the tool. If you use the tool, the 3% goes to 0 because the tool would have caught all of that and prevented it, right? So that number could only grow even in Rust because the tool gets better every day. So
how comprehensive is the tool? Like, do you have like a set number of things you're checking and you're just adding to that constantly? How's it work?
Absolutely. So we have about 80 lints right now. So that means there are 80 flavors of breaking changes for which, if they happen, we could construct a program that gets broken by that breaking change. So we could constructively prove that something bad happened. Either that program doesn't compile anymore, or it triggers undefined behavior, so it would be caught by Miri, Rust's undefined behavior scanner, or something like that. So something very obviously goes wrong based on the thing that we found, and we can offer constructive proof of that. I also have a list in an issue on the project's GitHub of like 150 more things that we should catch that we don't catch yet. And on a fairly regular basis, new contributors to the project come in and they go, this bit me last week. I'm going to check this thing off the list. And they come in, they write a lint, they open a pull request, we merge it, and the next release, that problem is never going to be a problem for them or for anyone else ever again, so long as they remember to run the tool in CI before publishing or on their local machine if that's how they publish. So it's more of a never again kind of a tool and not really a perfectionistic, idealistic sort of approach.
Yeah, exactly. Yeah.
I love it. So that knocks off Rust though, and you got something you're working on in Python. But of course, there are many programming languages extant and many ecosystems, so some of which nominally do Semver. I mean, there's also the ones that just don't do it. I mean, that's the other thing with, first of all, you have to buy into Semver, but then also the communication of like how you do Semver. Forget the tooling, just like I'm sure there's different ideas of what Semver is, even in the minds of one person probably. But you know what I'm saying? Like, yeah, we do Semver, except for the majors because we want to have a marketing opportunity. And so we throw it out the window when it comes time to like market. Because that's a communication problem as well, and one that many people dislike Semver because of, right? They can't market their big releases.
I actually think that is the biggest unsolved weak point of Semver. Like more than the philosophical, what is a bug fix problem? Because that one's really one that we can just agree, kind of make a definition, make a contract, and run with it. Everybody can get on the same page. Maybe I don't like the contract you picked, but I can at least understand it and follow it. The fact that versions are also a tool for marketing makes it very difficult for projects which do Semver and also do breaking changes to figure out how to use their marketing. Now, Rust itself as a language has just said, we'll never ship a breaking change, problem solved. We'll tackle marketing in entirely other ways. Ember.js famously is like the most Semver project ever, and has struggled enormously with this because the JavaScript community looks at big releases and thinks, this is Ember.js 5 or Ember.js 6 coming up in however many months from now. Sweet, big cool features, because when you look at React 19, you get a bunch of cool features with it, a ton of stuff, and some breaking behaviors that they, slowly built up to over the course of the React 18 lifecycle. But then you get to Ember 5 and it says no new features. And you say, I'm sorry, what? Because Ember says, no, the only thing we use major versions for is removing deprecated code. And in some ways that's very powerful because it means that you can think about how you schedule in updating to minor releases, updating to long-term support minor releases. And then, okay, if an Ember release comes every 18 months, I can just bracket in, I need to have these deprecations cleaned up by time X, whatever that ends up being. That's really powerful. And you also know that you're not coupled to the existence of these new features for I have to get through these breaking changes first. That's great. But how do you tell that story? And I would put it as a former Ember Framework core team member who thought about this a bunch. we never figured it out. Like Ember tries to use additions to do this, which is similar to Rust's notion of additions. It's this kind of big, everything comes together at a point in time. We've updated all the documentation. All the APIs are coherent. Everything is in a place where we've made this really significant change to the ecosystem. It's a good idea that in the Ember case, I don't think has worked. I think it has sort of worked in Rust's case because it comes with other trade-offs around being able to make changes to the surface syntax of the language that are opt-in but breaking and backwards compatible. That's a whole different podcast and a different discussion. Super cool, worth talking about. But I don't think we have a solution for this particular dynamic of if we're going to Semver seriously, how do we communicate here's a big marketing moment. Ember's Editions is, I think, a step in the right direction there. But I've sometimes wondered if we don't need like marketing version as just a totally different thing. Mm-hmm. And I think that's what Editions points at. But I don't know. I think it might also be a matter of seeing somebody with enough scale try it, because Ember's very small, has a lot of great things going for it. But, if you're 2%, 4%, whatever of the broader JavaScript ecosystem trying that kind of thing. Whereas if React did it and did it that way, I think it might stick more in people's minds of, oh, this is how this works. Now, I don't expect the React community to try that, but you could imagine that a bigger project might be able to influence the way people think about versioning more effectively by taking that swing. But it might just also not work and we'd have to try something else.
I also have a maybe strange idea for how to maybe fix this. What if we made breaking changes not actually require major versions and still adhere to Semver? So we could actually reserve major versions for marketing only. Crazy, I know, hear me out. And just to be clear, I am not planning on building this until there is a lot more funding flowing to Cargo Semver checks and the other projects I'm working on. But it is a genuine idea that I think could work. Imagine that we could detect with very good confidence breaking changes in a mechanical fashion. And based on the change that we see, right? Like, this argument is now necessary in functions as opposed to previously we could pick up a default whatever. If we could generate code mods, rules for how to change code so that it's compliant in the new version and preserves the behavior of the old version, right? Where when I run cargo update or, the equivalent in NPM or pip or poetry or whatever, in addition to picking up the new version, it also goes in and tweaks my uses of the code that it updated dependencies for so that I'm no longer broken, right? This still satisfies my objective of the build is still green before and after, right? And there was a breaking change in the API, but that breaking change only affects me the next time I write a piece of code that uses that API and not any of the existing uses, right? So in my book, if you ship code mods that are of sufficient quality for all of the changes that are breaking, that does not necessitate a major change to adhere to Semver, right? Because no human action was involved in making that change. That change is completely mechanical, right? And at that point, we can say major versions are for marketing and everything else can be minor. Now, obviously, this requires a bunch of tooling and infrastructure that we don't have, and tooling and infrastructure that I would love to build if someone wants to send a lot of money to my GitHub sponsors page. But I think it's a viable future that we could have that solves both this problem and a lot of ergonomics and usability problems of Semver as well.
Yeah,
that's interesting.
It's a cool idea. Very much feels like a boil the ocean kind of a thing.
That's what people said about Cargo Semver checks when I started it. There was a lot of, this will never work.
I think one of the things that strikes me about that is that it works if and only if you can make it, as you said, genuinely 100% on the code modability side of it. And so I think it gets at the human communication dynamic piece of it again. One of the things I think about a lot is, okay, if this operation used to be, to use the standard performance language O of 1, it's constant time access to get something out of this data structure. And now I made a change to the performance of that data structure that gives it way better memory characteristics, but now makes it O of n. So it scales with the size of the number of items in the data structure. And the surface level API didn't change. that's a breaking change in my book, because you can radically impact the performance of your end user systems by doing that. But it's not going to be statically catchable by the kinds of things that could code mod it, because the API hasn't changed. And so I think there's an interesting challenge. Like, I think what you just described is good, and it's actually kind of the improved version of what Rust and Ember and some other JS frameworks have tried to do, of when we ship a deprecation, we also ship a code mod with it that moves you to the new API. And that goes a long way, especially if it's one of the ones that's 100% rather than like 80%. And now you have to do the last 80% yourself. And yes, listeners, I said 80% both times on purpose, because that is my experience of how that goes. You solve that 80% and the last 20% takes another 80% of the time. I think the other challenge there is making the thing trustworthy enough that people feel like it's safe to do that as part of their NPM update or cargo update or whatever it is. And I think you probably have more leverage to do it in an ecosystem with types than one that is without types, for the simple reason that it's easier to be confident that you got it right with that code mod. Not necessarily impossible in Ruby or JS or whatever, but easier.
It seems like for incremental adoption, I like the idea, Predrag, but it seems like for that, just simply adding a prefixed, I mean, Chris is kind of joking, but maybe would work kind of like, why don't we just add another number? That if your version has 4 numbers, the first one's marketing. If it has 3 numbers, then it's just the old style. And so you could just have that and not having to fix that problem of the breaking change with the code mods thing, which I still think would be a worthy goal and one that you should definitely get sponsored by somebody to work on. But it seems like it's really far away from something that we could use.
Would it always remain like 1 in front of that? So if you had 4 numbers, would the number 1 or number 2 be like, because that's the thing too with marketing, is not to say negatively about those folks, but they're not generally in the minutia like we are here. And there's a thought process break where what they think is marketing is simply what is acceptable, what's praiseworthy, what's celebratory, not so much practical and pragmatic in the application state.
Right.
So it's really just window dressing. It's not really useful. It's just there to be there to represent.
Which is why it's optional.
Right.
There's almost a sense in which the ordering is the opposite of what we want for marketing reasons.
True.
In that the minor release, which comes along, whether it's on a cadence like Rust or Chrome or whatever, where it comes out on a predictable timeline, or where it comes out whenever it comes out, the minor release, if you think about the Semver semantics, is actually the marketing excitement. It's the we got new stuff moment. And yet it's the second slot.
Right.
And the something broke is the first slot, because there's a good reason for it, which is it's the one that's going to hurt the most. Hopefully the other ones won't hurt, but doing the breaking changes is going to be some work. That's why it's breaking. I don't have a solution for that, but it does feel like they're backwards that way. And in fact, when I was making slides for that talk, one of the things I noticed is that when I went to explain it, and I think I did this when I was talking about it earlier, you want to explain the order upside down. You want to start with patch and say a patch is a bug fix, and then a minor is a feature or a bug fix. And then the major is breaking changes and maybe also a feature or a bug fix, but you almost end up kind of backwards from the Semver ordering. And I do kind of wonder if the move, to your question earlier, Jared, about is Semver even the right shape? I think if we were to take a different swing at it, we want to keep all of those bits, as it were, of data, but we might want to find some way to treat them as a different kind of ordering. And getting really nerdy here for a sense, it's not clear to me that when we think about like partial orders or total orders in a deep type theoretic sense, that's actually quite the right model for versioning. And the marketing part becomes a piece of that, because the marketing thing may really be very distinct from when breaking changes land. And both of those are really important bits. But it feels really weird to say that I have version 2. Where that's the marketing version, 4, where there have been 4 breaking changes as part of marketing version 2. That feels weird. And then all of these other feature numbers along the way as part of it. And maybe just thinking about different ordering schemes or ways to kind of decouple those further could be a part of the future here. You need all of the bits, though. You need the marketing bit somewhere, and you need the breaking change bit somewhere, and you need the bug fix bit somewhere.
Mm-hmm. One more thing that's interesting is that there'll be names. So like Dragonfish, for example. Not only is it, and I'm talking about TrueNAS here in this case, TrueNAS scale 24.04, which actually is not Semver. It's I've learned today it's called Calver. I didn't really even, it makes sense, but I didn't consider the fact that it's the 24th year and the 4th month. So they have a release cycle. Everyone understands that that's also, they've adopted the Ubuntu way as well, which is, year and month, and they have a release schedule, but they also call it a name. And in the case of Ubuntu, they have certain names. I think they're all based on Pixar, if I recall correctly. And then Dragonfish, in the case of TrueNAS scale, this is what they named it. So they add one more nomenclature, which really is their marketing term. So I wonder, is the 4th number really required? Can you just leverage a naming schema?
That's what Ember has tried to do. And again, that's the question of does that work or not? I think Ubuntu is interesting as an example. I'm not in that ecosystem anymore. I used to run Ubuntu for a bunch of things, but I never, even when I did, I don't remember remembering the names very well. I remembered the cadence. But Calver's interesting, Calver being calendar-based versioning, because once again, you're back to read the release notes as your mechanic for did this break something that I depended on? Because Calver tells you when something happened, but it doesn't tell you what happened then. It's in that way kind of like Solover, which says even less. I like Calver better because it at least gives you a date. That's useful. But both of them have the problem of they basically reduce to something happened. Right, but what? What happened is what I want to know. And I think the big name for it, the branding name for it, as you're saying, Adam, it helps.
Because then you can actually use something. And I was incorrect. I think it's Debian that leverages Pixar characters, right, Jared?
Yeah, Toy Story was where they started. I'm not sure if they moved on from there.
And I don't know. I think Ubuntu actually has a double name. And I'm not sure. I'm trying to figure out quickly because I messed up.
Yeah, they're like alliterative animals, aren't they?
Yeah, alliterative animals is exactly it, I think.
All right, Warty Warthog was 4.10. Yeah.
Warty Warthog, I remember. But I do agree. I never go back and remember which one was. I know Sid, because that's the experimental branch. That's a great name for that.
Yes.
But then the rest of the Debian releases, it was was this Woody? Was this Buzz? Was this? I don't know, because they're important as they come up, but historically I just forget which one's which because you have a bunch of them over time. So they kind of lose their meaning. I think Calver really has a place with products, less so than with libraries. Because I think just knowing, it is nice to know when was this product released because it's right there in the version number. But I agree, it really doesn't tell you much about that release, which is fine for products because you have all kinds of other things around them. But with libraries, we want to know more details, right? This is business, not fun kind of stuff, right? We don't want to break our businesses.
And for libraries and frameworks, I think of Semver as Calver with an extra optimization slot, in a sense. Think about it this way.
That's good.
If every Calver release, you release twice a year, is allowed to make breaking changes, right? That's just as if you updated the major number in every release. But every so often, there's a release that does not make any breaking changes. Maybe it's just some patches, maybe it's some new features that don't affect existing functionality. If you tell me that you've made such a release, I don't have to pay as much attention when upgrading. I will expect that I can just let my package manager from my ecosystem handle it for me with no action from my part, right? Now, you could be conservative. You could say, I'm not sure, maybe I've made a breaking change and release a new major every time. Right? And that still adheres to Semver. That also happens to be Solover in practice. But if you tell me that you've made breaking changes more often than strictly necessary, then you're shifting the effort on my part, like Chris was saying earlier, right? The more you can tell me that based on your gut feeling, you have not made breaking changes, and ideally based on the best available tooling for your ecosystem, you also have not made any breaking changes, the more often I will be able to patch feeling confident about it, and ideally not spend 6 hours then chasing type errors or worse, misbehaviors in a system that I've deployed to production. Right? So I think Semver is just an optimization over what we could get otherwise, because I optimize away the necessity of me reading the release notes religiously for every one of the 400 odd dependencies that my project depends on.
I do think that is suggestive, though, of the value of calendar-driven releases. I think predictability in versioning is actually really, really helpful in that regard. So the fact that TypeScript releases basically quarterly is really helpful for planning around it. The fact that Rust releases every 6 weeks is really helpful for planning around it. And it's helpful for all the teams who work on those projects because it gives them a schedule. But it also means that you can think, okay, maybe we don't have the appetite as an organization to take a TypeScript update every quarter. But knowing that they come out quarterly, I can bundle it up and say, I'm going to do this every 6 months, or I'm going to do this every year, or whatever the cadence I choose. And it's very difficult to do that in ecosystems where that kind of schedule doesn't exist. So historically, I don't think C# has, and they may have shifted this in recent years, but it wasn't the case for a long time that there was a predictable cadence. They came when they came, and that meant you couldn't plan around that. For a long time, Ember didn't do that, and you couldn't plan around it. React certainly doesn't. React 19 comes when React 19 comes, and the entire ecosystem gets to go, woo, let's figure this out now. Okay, this is going to be a ride. I think having a schedule, one of the things that Predrag just said, they got me thinking, is it would be really interesting if your major version intentionally adopted the calendar versioning nomenclature, because that would pull you out of the frame of thinking about it as a marketing version, because 2404, like 24-04.01.1.2 doesn't make you think, the marketing version 21-04, like that's not a marketing version. No. And that might be enough of a shift. And you could still codify that, like, this is a system that tools know how to process as Semver-ish in shape, because it's still predictable. It's still month, year with a dash in between them. It's trivial to parse. But doing that might give you, as an ecosystem, a chance of much more clearly distinguishing, okay, this is a timed release that bundles up the breaking changes since the last timed release. And in effect, doing the kind of thing that Ember's trying to do now, and that others I would like to see try to do for breaking changes, where they just, Angular does this, Node does this, lots of things do this. Lean into it. I think Angular and Node could do exactly this. And instead of saying it's Node 22, you could imagine, especially since they have a 6-month cadence, that it's Node 24 dash whatever. I don't remember when the next one comes out. I think September or something. So 24-09. And then the patch and bug fix or patch and feature releases in it. That could be a really helpful way of distinguishing the marketing dynamics.
Hey friends, every time you're out there in the world and you're on public Wi-Fi, let's say a hotel, a cafe, an airport, you're traveling, you're at a friend's house, and maybe they're not very trustworthy. Maybe they are, who knows? You're not secure. Any hacker on that network can gain access to steal your stuff, take your personal data, and do what they want with it. And it doesn't take much technical knowledge to hack someone. Just some cheap hardware is needed. A Raspberry Pi. I think your data is valuable. And I think hackers think so too, because they can make up to $1,000 per person just selling your personal information on the dark web. Could be your phone number, could be your address, could be your driver's license number. Whatever they can get their hands on, they're going to sell it. $1,000 per person? That's crazy. But ExpressVPN stops those hackers from stealing your personal data by creating a secure, encrypted tunnel between your device and the internet. And what I appreciate most about ExpressVPN personally is it is super secure. It would take a hacker with a supercomputer over 1 billion years to get past ExpressVPN's encryption. And it's also easy to use. Fire up the app and click one button and you get protected. And that's what I do when I'm in a cafe or an airport, or I'm out there and about. I'm getting my tires changed. I'm getting my oil changed. I'm using ExpressVPN to protect myself. And you can too. Go to expressvpn.com/changelog. That's expressvpn.com/changelog, and you can get an extra 3 months free. Again, expressvpn.com/changelog. Let's draw a corollary here potentially, because arguably Ubuntu has become one of the most popular flavors of Linux to install, right? Like, a lot of people use it. They were the first to come up with LTS. They do use, this nomenclature you just mentioned. I just wonder, like, is there a reason potentially beyond the quality of the release cycle, the team behind it, what they've done, etc., has their ability to popularize LTSs to be more trustworthy over time, as well as this nomenclature of 2404 or 2204 or 2004, however it frames out. Do you think that's been a corollary to their success?
I think there are two values there. One is the clarity in communication, and the other one is the clarity in scheduling, both internally and externally. So the communication that LTS says, if you use this, you are not on the hook for worrying about security patches. You will get those security patches for a predetermined period of time, and so you know what you're signing yourself up for, right? And being able to credibly make that commitment is valuable. The other half of it is the schedule certainty, both internally and externally, because I remember some time ago, I was going to build a new computer for myself, and I looked at the calendar and I was like, oh, what I should do is I should wait for another month, because there's going to be a new LTS release out. And so I don't want to set up a brand new Linux install when I'm going to have to go through the whole process again in a month. Right? And knowing that calendar, is dependable and is going to happen on a predictable cadence is very, very valuable. I imagine for a large project like that, it's also very valuable internally, because if you're trying to ship a new feature, you don't have to worry about, like, will I make it into the next release on time, depending on when that next release is. You know when the next release is, you know when the deadline is. It's the same deadline every year, right? And so you know where you stand. You don't have to do any horse trading with the release manager or PM or whatever, and exchange favors or whatever else needs to happen. I think it eliminates and streamlines a lot of that effort that normally has to happen whenever you're trying to wrangle a big project toward a release. And I think that's useful both for the project itself as well as for people depending on it downstream.
At the same time, though, even with your scenario where you want to wait a month because you know the date, at the same time, if you have confidence in the upgradability from one version to another, like the .10 release in particular, Jared, I've disclosed you behind the scenes some fear, like, oh my gosh, I've got to upgrade my Ubuntu. I'm going to wipe the system. I'm going to back up and I'm going to start from scratch. But I've learned and I've come to, trust their ability to architect good software to give me an upgrade path. And it's also like, this is probably specific to Linux, that as soon as you log in, it lets you know, hey, you've got an upgrade availability, do release, whatever it is for the command you could run. I've learned to trust that. So at the same time, I might be, my, 21.10 of Ubuntu can easily upgrade to 22.04 safely. And I've done it once before and I'll do it again. So there you go. So I won't wait the month because I have trust in their ability to release properly. But I do think it really comes back to the beginning of the show when you said Semver is really about communication. It's a machine readable way to communicate for both machines and humans that communicates in a lot of ways. And the challenge really is like, how well do people adopt it? And are there different permutations of it that misalign or, unalign, I suppose, that makes it challenging to do Semver? And like you all said before, if you have to have a PhD in it, is it really worth doing? That's true. But I think, coming out of this conversation, I'm not thinking Semver needs to die by any means. I'm thinking it needs to live and needs to have people like you behind it, but it is super challenging.
And I think to your point there, the more that you can make those kinds of transitions seamless, this gets at exactly the kind of thing Predrag was describing around code mods. Even if you are shipping a breaking change, like even if you don't adopt the slightly more, I'm still mulling on it proposal there of it's not breaking as long as the code mod is good enough. even if you don't do that, if every breaking change you make, every deprecation you make comes with a good enough code mod so that when you do actually make that breaking change, you could have the kind of confidence that you're talking about, Adam, that you could know that when I go from React 19 to React 20 or Laravel, whatever the current major is, to the next one and so on, that it's going to come with that kind of automation. And that becomes a norm across the ecosystem, or at least for those foundational pieces. I think that would give you a lot more confidence to say, I can take this upgrade that is going to be breaking, but I'm not going to be broken by it because the ecosystem has built this value around this socio-technical contract we've set up with Semver, and we're going to apply all of our technical skill to make the social part of it better.
I also think there's a lovely positive feedback loop going on here. We've noticed this. I think we're all on the same page that releasing your software more often is better than not, right? I'm thinking in the context of, say, like a SaaS application, right? If you release once a year, it's going to be a much more painful release cycle than if you release every week or every day, right? Because big changes are hard to test and small changes are better. I think there's something similar to be said about software and the rate at which you apply upgrades, right? If you accumulate 400 version upgrades and try to do them all at once, I mean, good luck to you. I just don't want to be anywhere in your blast radius, right? If you try to upgrade them, once a week or even once a day, and you have high confidence in the tooling, then good things happen downstream of you. So more good things happen, and so on and so on. The primary method by which cargo semver checks, the Rust semver linter I built, gets adopted is that somebody has an accident, rolls a natural one, and right? I mean, it really is an accident, right? Like they didn't mean to cause a breaking change. It just happens to them, right? And then they break somebody, and then somebody opens an issue and says, "Hey, you broke me. Like, this is bad. You need to fix this." And a lot of the time, someone says, "Oh, by the way, like cargo semver checks catches this," and then no fingers are pointed, no blame is assigned, but you very quickly see that project adopt cargo semver checks for the next release, right? And if they adopt cargo semver checks and they ship fewer breaking changes, then libraries that re-export their API and, rely on it to provide some capabilities downstream, they get broken less often. They might also adopt cargo semver checks because they see it works well. And all of a sudden, a rising tide lifts all boats, right? Everyone's software is better off. We can all be updated more often, so we all benefit from the new features faster. We get better performance. We get, security patches patched more promptly and not, festering open for months while we try to figure out how to navigate our way through all of the changes that we've accumulated because we haven't updated any piece of software since, 2017. Right? I mean, I wish I were making this up, but like these are things that happen in the real world, right? Like, wasn't there the case that a large number of government machines all over the world are still running Windows XP, right? They don't do that because it's fun.
Why do they do it?
It's very difficult to upgrade.
Okay, I wanted you to say that's all. To be super clear. Yeah, it's hard to upgrade. So when you trust the upgrade path, it's a little easier.
Exactly.
But that comes with maturity too. XP was super old, right?
It's important that you not just trust the path, but you walk the path regularly.
Right.
Because then you have smaller downstream effects because you have less change every time that you make that change. I think that's wisdom.
Hasn't Microsoft Windows been notoriously hard to upgrade every new major version? And that been like, until maybe more recently, has it been less hard? Whereas like Mac OS, for example, which is a popular developer machine, has been generally easier to adopt new versions, and they've made the upgrade path semi-easy. I mean, for the most part, pretty easy.
Interesting. I've had the opposite experience personally.
Really?
Your mileage may vary.
Developer machines might be different. I mean, if you're installing specialized tools, we feel that too. We do audio production, so there's times whenever I think on my main machine, I may have just recently gotten, I don't even know what the latest version of Mac OS is, so I'm not a great example of it. I usually wait 1 year to a half a year just to make sure all their kinks are out, because Adobe is always behind, and Adobe is our suite of production tooling, and so I know there's some level of latency between the two, and I just can't risk it because I want to make sure you all sound amazing. Our shows are awesome, they go out on time, and I can't be the one that's the bottleneck on those things because of my desire to be on the latest Mac OS. So that aside, I do think the upgrade path generally is easier in my experience with Mac OS.
I think that actually gets at something really important that we haven't touched on so far, which is that a concern for backward compatibility, which can make upgrading easier. In this context, the fact that you can still run 16-bit DOS applications on Windows 11, which is amazing in a lot of ways, also makes it much harder to move the platform forward in other ways. So Apple, by contrast, you want to run a application from the 16-bit DOS era? Maybe if you're running it in an emulator written in JavaScript, you can do that. Cool. But on the operating system, absolutely not. On the other hand, that's part of what makes it really easier. I'm not going to say easy because it's an enormously hard task, but easier for Apple to do something like ship an architecture transition from x86 to ARM and pull off the whole thing in a matter of like 2.5 years, 3 years, because they're willing to just cut their losses for backwards compatibility sometimes. And we see the same thing for a higher level of the stack, that a framework that is willing to make breaking changes on the regular can move forward faster, but that's more cost for the people upgrading. By the same token, somebody who's really committed to backward compatibility can bring along all of the people on their ecosystem very well, but it can often be much harder for them to get the benefits of trying new things. And I think here, actually, the example of React and Ember in the JS ecosystem is a really good example of this. Especially, it's less true now. React has gotten way more thoughtful about breaking changes, but in that kind of mid 2010s to, like 2018, 2019 time, React would ship breaking changes much more than Ember would. And React got to try a lot more things than Ember did. On the other hand, I've talked to a lot of senior engineers at very large companies who got stuck on React 16 and never moved on. And that's less true for Ember, but Ember got to try a lot fewer things along the way. There's just a fundamental tension there that then gets manifested in your versioning. And the versioning is often a symptom rather than the cause in that case. It's telling you a true story, but the story it's telling you might be telling you something else about the dynamics. The fact that Windows can still run DOS 16-bit applications has other consequences for the kind of incoherence of the Windows ecosystem. But that's a really big benefit if you're an enterprise IT administrator who wants to not spend a lot of cost on upgrading applications that just work for you. Trade-offs all the way down.
I also think that good tooling on the part of language developers can massively tweak whether this problem is insurmountable or not that bad. It's always somewhere on that spectrum, right? Rust has an interesting feature that I really did not appreciate fully when I was starting out, which is that you can have multiple major versions of the same library in your project exist at the same time. And like Chris, you were just saying, this is not a decision that was taken lightly and is not something that is available for free. For one obvious consequence, it makes the version resolver much, much more complicated, right? Because it now needs to solve a problem that is much bigger in scope. But what that means is that if, Chris, you wrote a library that depends on foo version 1, and I wrote a library that depends on foo version 2, and now Adam wants to use both of our libraries, so long as our libraries are not something extremely fundamental, like a framework like React that expects to be, in full control of everything going on in the environment, Adam can probably just use both of our libraries and be completely fine with the fact that the two of us can't agree on which version is the correct version of this dependency that Adam doesn't know or care about. Right? Now, this is also not for free to Adam, right? It means that when Adam compiles his project, he has to compile 2 versions of this dependency and not 1. So maybe his binary size is a little bit bigger, and maybe there's a little bit of bloat in the development environment and stuff like that, right? But the alternative is Adam having to pick between your library and mine. And I can tell you from the Python 2v3 transition, that is not a pleasant experience to be in. I mean,
bad time.
I lived it. I made good software money, just like moving stuff from Python 2 to Python 3. And if I could have made half as much while dealing with none of that, that might have been a worthwhile trade.
I think that also gets at different languages have to make different trade-offs there. NPM allows that, as do Yarn and PNPM and so on. But you generally are fine with that on the server and extremely not fine with that on the client, because your bundle size ends up mattering enormously. And so you have to be able to pick different trade-offs. And the NPM, et cetera, one is hard because it's trying to serve both a server ecosystem and a client ecosystem, a browser ecosystem. And those just have fundamentally different needs. One thing that Rust doesn't do, and NPM theoretically does, and Yarn and PNPM actually do, is support the idea of peer dependencies, which is this secondary dimension to all of this, where you want to be able to say, I want to support a range of versions of this dependency of mine, and I want to maybe even be able to test against them. And in principle, that's possible in the NPM ecosystem and more or less nowhere else. I think it's an underinvested area. If you're building a new programming language, you should bake peer dependencies in as a first-class concept, because frameworks, React being the classic example, but in Rust, Tokyo is a very good example similarly. Things that sit at that foundation level that everything else builds on, you really want to be able to say, my library is currently built against the latest version, and Predrag's is built against a version 4 minor versions back, but both of us just say, we have a peer dependency on the same major, and your resolver can now say, I'm going to get the version that satisfies both of these, and neither of you ships a direct dependency on it. You both specify a peer dependency, and that can, quote unquote, just work. And it's a very powerful thing that mostly doesn't exist. Again, Yarn and PNPM finally have gotten this right in about the last 2 to 3 years. But it allows you to pick a different set of trade-offs. And to bring this all the way back around and very full circle to does Semver work? It only works because you have that ability to communicate those sets of constraints, that these share the same major version, and they might differ on which features they're using, but they share the same major. And so you can actually build tooling around that. And you can't do that without something shaped like Semver, even if we iterate on the details along the way.
Well, you answered my unspoken question, which was, is there a better way? And is it too late to unadopt Semver? Because that was my unspoken question. It's kind of been camping out in that area. It's like, is there a better way? Because it's fraught with a lot of issues and a lot of challenges, but is there a better way? And I think you just kind of answered that.
I think the best place to take it from here is to invest in tooling that we have and make it work in even more of the cases. Starting from scratch, we're going to relearn a lot of the same very painful lessons in a much longer time scale, I think.
Right. Well, let's leave folks with some waypoints, Predrag, to some of the tooling you've been building, perhaps, Chris, how they can connect with you to plug into this conversation and have say, because there are so many details and so many little avenues and ways that we can go with this. We could talk about it all day. We may walk in circles. Semver checks. What'd you call it? Crate Semver checks.
Cargo Semver checks.
Cargo Semver checks seems like maybe state of the art for people who want to build similar tooling for their ecosystem. We have to permeate all ecosystems with this tooling so that everybody who's doing Semver can actually do Semver as well as we possibly can. So maybe that's a great place for people to either help out in Rust or look at what you're up to and emulate in their language of choice.
Absolutely. And the infrastructure that Cargo Semver checks is built on, the core piece is called Trustfall. It is a weird take on a database query engine that is a topic for a whole other podcast episode sometime.
Okay.
But the key thing there is that it's language agnostic. So it has bindings for Python. It works in JavaScript. You can run it in WASM in the web browser if you wanted to. You could call it from anything. And so you could use it as the foundation of a Semver linter for another language. That's in fact how my Python Semver linter works as well. And I'm trying to talk Chris into building one for TypeScript.
I already have too many projects, but if somebody else wants to partner with us on it,
there you go. Then what? What should
then
they do?
reach out.
Then reach out. Okay.
Yeah. So
Finish
on
that
my
sentence.
end, Predrag, I'll let you finish and then I'll...
Yeah, and Cargo Semver checks and Trustfall are both completely open source. So if someone wants to come in, learn how to write some lints, check out a weird database, maybe write some database optimizations or, whatever you're interested in, very happy to do that. Like I mentioned earlier, I worked with 4 college students who did some tremendous work and honestly made Cargo Semver checks into what it is today. So if 4 people who hadn't even finished college yet could have such a spectacular impact on the ecosystem, then anyone listening to this podcast could absolutely have a huge impact. So come talk to me. I'm very happy to help.
Yeah. On my end, I will say, if you're in the TypeScript community, do look at semverts.org, semver-ts. The other thing is, I'm happy to help someone get up to speed on how you would translate that spec, which it's very long and very detailed because it has to be, how you would translate that into a query rule set for something like Trustfall, because I do think we could do it. And I think we could do it using a lot of existing infrastructure like TypeScript ESLint. I don't think it would be a boil the ocean from scratch project. But the other thing I'll say is, if you want to think about, hey, how would we do this for Elixir, especially as Elixir starts pulling in types and makes a lot of these things even more tractable than it would already be today? I'd be very happy to talk to you about what a semver-elixir.org kind of spec might look like. And I would actually love to see these kinds of things emerge more generally, of what is it you need to think about. Cargo has a 10,000 word document, which you can read through and gets added to on the regular. TypeScript now has one, though I'm basically the only maintainer. I would love other people to contribute there. And if we started building up that kind of ecosystem of projects for a variety of languages, what does it look like in C#? What does it look like in Java? And started making that more of a norm. What does it look like in Ruby? That can also get a flywheel going, because someone doing the time to think through that, and then a bunch of other people taking the time to codify that into something like the Trustfall rules engine, build a schema, and ship those kinds of things, we could make this a norm that is, maybe we're having a conversation 5 years from now where tons of languages do this and it's just normal. That would be amazing. And it's just time and effort. And that's a big just on that statement, but it is a just. These things are actually tractable, solvable problems. So come talk to me. You can find me at chriskrycho.com, and email and whatnot is all there. I'm really easy. I'm at Chris Krycho everywhere because it's a globally unique identifier. There's only one of me on the planet. So
that's all right. Good for you.
Got your own
easy
quid.
to find.
My blog is
awesome.
Predrag, because .ag is a
you go.
TLD, and it's an uncommon enough name that
Oh, he's a TLD hacker.
it's just
Love it.
Predrag.
Love it. Well,
That's cool.
you guys make sure we get links to all of those
Absolutely.
things. I got
Yeah.
Hiram's Law. We have some other stuff that we'll throw into the show notes so everybody can just click through versus having to type and memorize and whatnot. Very cool. Adam, anything else?
My thought after this conversation is that there should be some sort of like consortium or working group or just like collective for Semver, because
People who care.
right, because you've got skin in the game, you do care, and you've got expertise that applies. And so just as you said, if you want to help somebody else in a different ecosystem, you're willing to help them out. I feel like there needs to be like a little group of you all folks who just care enough to cross-pollinate so that the whole entire ecosystem of software gets better, because it's not about camps. That's why this show is called The Changelog and not the Rust Show or the Ruby Show or the whatever show, because we cared more importantly about software at large, the intersection of software and business, and all the fun things you know about this show. That's why we went that route, because we cared about software at large, open source at large, and just really the direction we can all go, the culture of software development. And so I would encourage you guys to consider, if it doesn't exist, make it exist. And if you do,
Semver Nerds.
yeah, Semver Nerds. There you go. I like that, Jared.
Come join the Semver Nerds community.
Is there a .nerds TLD? Because then we
should
could have
be.
semver.nerds. That would be the
There
best.
needs to be.
There should be.
Yeah. Predrag will figure something out. Awesome. Thanks, guys.
Yeah. Thank you so
for
much.
coming
It's been
on.
awesome.
My pleasure. Yeah. Thanks for having us.
Thank you for having us.
Okay, Semver Nerds, unite. It is time to communicate better software through versioning, and I've changed my mind during this podcast. I came into the show, and maybe you can tell, because I was kind of against Semver. It's kind of hard to understand. It's generally been problematic for me. Others may have different experience, but after hearing Predrag and Chris's arguments and their stances and their experiences and their passion, really, and more so, their expertise in Semver, I'm thankful they're on the front lines, for one. And number two, I'm kind of for it. It does communicate, it has a place, and we just need to keep working to improve it, working to adopt it, and working to better help folks understand exactly what Semver is, where its place is, and how to use it. What do you think? Come hang with us in Slack, changelog.com/community. Free to join. By the way, this show has a bonus for our plus subscribers. Head to changelog.com/plus. It's better. Yeah, it's better. Changelog plus is better. Drop the ads, get a sticker pack, bonus content, closer to the metal, all the fun things you get when you directly support us through Changelog plus. Once again, changelog.com/plus. Okay, a massive thank you to my new friends over at Retool. Well, I say new friends because I made some new friends. I went a couple layers deeper. I talked to David Shu, the founder and CEO. I talked to Tamar Ben-Sharkar on behalf of Neon recently. And I've been talking to Daniel Kim behind the scenes, making all that happen. It's so fun to work with partners and sponsors like Retool. And they're awesome. Check them out, retool.com. And of course, to our good friend Faraz Abukadije, representing Socket, socket.dev. Ship faster, security dependencies. Check them out, socket.dev. And also to our partners over at Fly. That's the home of changelog.com. We love them. You should love them too. Check them out, fly.io. And to the beat freak in residence, Break Master Cylinder, those beats, so banging. Okay, plus subscribers, stick around. Everyone else, we'll see you on Friday.
Predrag, you wrote one of my favorite blog posts of the year. You wrote it on April Fool's Day. It was not a trick. It actually happened. This was the Wi-Fi only works when it's raining. And I didn't know you then. I know you now. I'm happy to know you. I shared it on Changelog News because I love this little story. Share it with Adam. I'm not sure if Adam saw this. Chris, you're nodding along, so you know this story pretty well. This is just a hilarious fact of life in the modern world. Can you tell that story just briefly for our plus people?
Absolutely. So it's a completely true story. It was part of a project called April Cools that a friend of mine started. We decided that it was a little bit tacky to lie to people on April 1st, and instead decided to pleasantly surprise people with true stories that are on topics unrelated to our usual beat.